This is a class speaking to looking at testing from the farm to pharma, looking all the way from where it starts in the field, being able to know what the potency is or what the number of other contaminants would be in a program or in a process, or also anything that you're doing with the testing side of hemp. Most people look at the testing side of hemp by having it be based on a certificate of analysis where they're trying to make sure that what is in their product is in their product, as well as making sure that it's below the current federal regulations of the 0.3% THC or potential THC. What we're going to do is look at a little bit of the background about the cannabis product and look at some of the effects, look at some of the practical theory of concentration, because part of the analysis of the compounds is looking at the extraction of that before you can analyze it. And then what's next? When we're looking at the number of compounds that are done in hemp, or because hemp is cannabis, it's just a variety that doesn't express as much of the THC, then we have other products that we're routinely using every day. So, well, Taxol maybe not, because it's used for cancer, and it came from a tree, and so much of that tree was being used for extraction rather than synthesis, and then they ended up being able to do a synthetic part of Taxol. Fungus for cyclosporin and antifungal. Willow bark, I mean, we would be chewing off willow bark if we were just looking for aspirin, but aspirin became a small molecule product. And then we also have quinine. So when we're looking at so many of these different products that we're using, and even lavender would fit into the same sequence, we're able to look at what are the variations, what are the types of products that we're able to use, as well as what kind of testing we would use to best get those answers. When I look at the cannabis plant itself, we mostly change it from looking at the marijuana side, or what classically would have been the marijuana side as far as high THC. And you look on the other side towards things that would be driven more towards what we would be calling hemp now. And hemp would be something that's less than the 0.3% total potential THC. When you're looking at that as a criteria, then you have a lot more products you can use. You can be doing polymers. You can be doing hempcrete. You can be doing tinctures. You could be doing flowers. There's a lot of different things that you could be doing within that range, and making sure that you're playing within that range. This is the actual production of the major cannabinoids we're talking about today, certainly with the CBD or THC or CBC. These major ones are looking at how the plant actually synthesizes it itself. You start off with CBGA as the primary, and then you go through a THCA synthase to be able to make a specific stereoisomer of THCA. The same thing is with CBDA, and that's the CBDA synthase. When you're moving through the process, you also have some degradation products that can happen in nature, or degradation that can happen throughout a process. And so those are the other things that you're really wanting to know more and more about. For example, CBNA. There's small amounts of CBNA depending on what you've done for a process or what kind of history that plant has been in. So when we look at some of the different types of compounds, one of the things that we have to think about is what it actually looks like. So it's not the same as it looks like on the paper. This is like trying to take lobsters out of a pen. So now what I have here is this is CBDA. There's a couple of very unique parts of this compound, and that's why the analytical testing takes a little bit more, or will be more and more important as time goes on. So when you're looking at this compound, you see the black are the carbons, the white are the hydrogens, the red are oxygens, and I have a couple of unique bonds in here where I've taken some of the carbons and made them blue. And that's the power of what the synthase does in the plant itself when it's making a specific stereoisomer. The synthase is making this isomer, and so in this case, you could have other compounds that would be possibly available, or you can actually do degradation and change the structure through inappropriate processing. But we'd have to know that as we're moving through. The other part we have here is we have the carbon dioxide, and the carbon dioxide shows very classically through heat or through energy from light, the fact that it will go away. So you have the CO2 going away, leaving CBD. That's important on some processes needing to have both compounds in there. Some processes demand that the throughput is done through having CBD, having the neutral form versus the acidic form. There's a difference in the solubility between those different compounds. The next part that happens is that you have THC. There are different varieties that really limit the amount of THC, because remembering to have the THC, you have to have THCA synthase to make that product. We'll speak about the fact that there's other ways to make the product through degradation. But you can see that the product is very similar. Again, having the decarboxylation. But when you're working through a process to know how specific and why we're having to know some of the challenges of the potency testing, is that this one, let's say this is THC. I'll take off the carbon dioxide group over here. So now this is THC. There's another compound. So this is a hunger enhancement, right? Appetite enhancement. And then if you have, I see dead people, and they shouldn't have done that. Just seems ludicrous to come up to the booth and just do something like that. So anyhow, if I have this, I have THC. If there were only 3 carbons on this, it would be THCV. So that's made from CBGVA, and then THCVA synthase. And that's an appetite suppressant. So between just those 2 molecules, just those 2 carbons on the end shows a significant difference in what the brain sees and what proteins are made. And so that's important to know, because even though it can't go from THC to THCV, you still can have breakdown products that happen with CBD. And CBD can very easily close up one ring and then become THC, delta-9 THC. So all of those things are important when you're looking at the process and then looking at the potency throughout the process. So bringing all this to bear when you're doing in a process, you have to know what you're starting off for on the cannabinoids itself. What's the plant actually made? So there's a number of different products that can be made from the plant. Some have no cannabinoids at all. Some have some cannabinoids that are specific. Now that you're able to do more and more of genetics, to be able to have things that just make CBG that don't have other synthases. And you're also able to have things that are now blurred on the line of where did the plant actually start. The potential of some of the plants, this just being one variety, but if there's a lot of possibilities that even through this paper showed that the number of components in the plant are enormous, but also this isn't the most enormous amount of material that comes out of a plant. So it's not just going back through and looking at the cannabinoids. There's the other flavonoids, there's different style waxes, And even the terpenes themselves have different mirror images. So you have a lot of different variabilities within a compound. And to measure those in a case, for example, here, looking at the phytofacts type of reporting, there's other reporting that's out there, but being able to look at the cannabinoids, being able to look at the terpenes, being able to also know the other components and being able to express those with customers' experiences is important on the entire production side. So even starting with the plant, being able to measure that that plant's major components as it's growing. And it really starts to be open to what are you going to find? It's not just, you're looking for Waldo, but you also have a lot of other components. Which one? How big? All the different things that you're looking for to be able to justify the testing. And if we look at the reality, there's so many compounds in there. And so when we talk about extraction, most of the time people are concerned about terpenes and CBD or CBDA in this case, but all the other compounds actually lead to an expression and experience. So if you're taking a product from a certain manufacturer, they have a process in place, and in that process in place, they're providing the same variety to give you the same number of components. If you switch over to another variety, then you're going to have possibly have a different experience, even though it says CBD on the outside. It's a very different plant as far as the other components that could be in there. Let's look at a little bit on how to do the sample preparation. So somewhere in the middle here, there's a plant, and you can test the plant by going out into the field or bringing compounds back in. You can also, at some point in time, that seems to be where the miracle happens. And that's the part where most people aren't looking at that process. So we're going to look at that process a little more closely, because it's possible to know exactly where you are in the process and where the plants are, even from the outdoor grow, having the outside plants versus the inside plants, knowing where the water is, knowing where different materials are. You see the landscape of hills, and you see the landscape of the underwater versus North Dakota, where everything is flat as can be, and you have a certain constant amount of water. That's not the same case in the rolling hills of Kentucky. So we're always doing extraction. Everyone's doing an extraction somewhere along the way. And what I like to use for an example is coffee. Coffee and tea are classical ones that we're going to look at in the same vein. So if I'm having a coffee and I have the beans, I'm making sure the beans are dried. I'm making sure that I haven't done too much bad to the beans. And then I grind them up because I need more surface area. Putting that big bean into the extraction device or putting it somewhere in a process control still isn't going to bring you that type of process capability. So why would I have a productivity? I want to make sure that I've ground it up so I have more surface area. So from the time you start off, you wouldn't take a coffee bean and then try and just put the coffee bean in. You would grind it up until it has smaller surface area. And depending on how much you grind it up, you also have a different type of product that you're making also. So if you're making an espresso, it's a very, very fine grind, and you also have to use a little back pressure. Well, that's not the case if you're just using your typical flow through beaker. When I do that, it's also a matter of we don't really take the time to make the maximum amount of coffee in the most productive way. We're looking for the caffeine, or we're looking for something else to be able to just have something that's warm and hot and has that bitter flavor for what we like. If you're looking at it for the caffeine, now you have to find the different beans that have a higher caffeine, or you have to add more into that matrix that you're pouring your solvent through, which also brings you to the part of what kind of solvent are you going to use? Are you going to use a solvent, for example, such as acetone? So you can use a lot of different products. You can use acetone, you can use ethanol, you can use propane, you can use CO2. All of those provide you that capability, but because you're running it in your house, most of the time you're choosing water. If you choose ethanol, you're going to get a great extraction, but you're going to be awake, but your productivity at work is going to be a little low. And so when we're looking at that, we're saying, well, do I make cold brew coffee or hot brew coffee? And even from the work on the cold brew coffee, putting it in the fridge, it can last a month. A hot brew coffee will not last that long. It slowly accumulates other acids and starts to do a more and more degradation, even sitting in the refrigerator. So you're getting 1,500 compounds out of a hot brew. You're getting only 1,000 compounds out of a cold brew. And some of those are providing a degradation pathway. As I look at tea, same thing. If I'm wanting to have a tea that I'm wanting to have caffeine, I'm not going to choose chamomile. I'm not going to be able to choose something that's got an herb in it that doesn't have caffeine in it, and I can't expect that I'm going to find it. The other examples of making sure that we have the right product is, I'm going to say dishes, clothing, cars, even on your own self. When you take a shower, you're taking a shower, you're putting on a cold solvent, you're also using water, you're using hot water. You have all the things, and now you're washing everything. And if you take a bath means that you're soaking in something and then trying to wash off everything. So both of those come into the extraction. Both of those on the bath size, for example, if you're measuring all the material that came off your body and you step out of the bath, you still got some of the stuff on your body. So already you're not going to get a real view of what you're really trying to measure. So each one of those has its possibility, and that is part of the testing. So what is the best concentration method? What is the best being able to look at potency on small mobile units all the way through? The first one I use is B. And B is botanical materials, integrity, and maintained to assure the concentration of the desired compounds in their natural form. And the natural form means that you're still going to be able to be changing things, and chemistry will happen on those molecules. When you have chemistry happening on those molecules, then what you're going to have to do is you're going to have to figure out a way to make sure that you're not destroying those chemicals. If, for example, I have terpenes and they know that they're very volatile, and I know that I have cannabinoids, if I'm using too much heat, I like to use a demonstration as follows. A lot of times what I had is back in the oh, I can already tell I'm going to break it. That's not good. So as I look back through, I had a pen that I had used, and I had seen that it was really, really good at erasing. And so therefore you could take a pen and you could be able to mark that pen. And so on this side, I have terpenes and I have cannabinoids. Wow. So what you're able to do is I'll show you being able to heat up this with a common hair dryer. I also wrote this up in Extraction magazine maybe 3 months ago, where I gave the actual directions on how to do this, following to amaze your friends and family. So even from that, you can see, this is dangerous. Even from that, you can see that what you've got is all the terpenes went away through the heating. Now, why didn't the EAT go away? Because there's other terpenes in there and oxygenated ones that aren't as volatile as limonene or myrcene. You have beta-caryophyllene, and so that one's more soluble like a cannabinoid. But notice the cannabinoids didn't go away under that heat. They will go under that under higher heat. My second magic trick is looking at CBD and CBDA. So you have the carboxylic acid group up in this area here. And what you do with a little bit of heat, because you can see the A there, I apologize with my hairstyle. I'm not very good with hair dryers. However, you can see that the CBDA goes away. And so both of these show very quickly how you're doing a transition. But if you continue to put on heat, you'll continue to do a degradation. So then how do we actually move from a degradation and being able to look what else is in that compound, that plant mixture? So E is effective concentration with efficacy and efficiency economics in predefined boundaries. So you're really knowing what you have first. And then S is for safety, and T is for testing with modern technology. So having something that allows you to do the modern technology. So now what I'm going to do is I'm actually going to do a little bit of a separation for you. I could have done this beforehand, but I want to show you how easy it is to take the tops off. It's so easy, even a PhD can do it, and it's kind of like cracking eggs. Well, if you're really good at it, you can do it with one hand. There. So I have these empty vessels, and these are set based on time. So the scientists in the audience, of course, going, well, there's a few other phenomenon that can happen here, but what you're going to do is you're going to look at this process and separate out a mixture of compounds. Well, now you have to figure out what you can use for a mixture of compounds, and I have a solution. These are COVID sealed, I can tell, so they won't be opened until the year 2024, but I'm breaking into them. I also noticed that on these they have an expiration date, which is shorter than Twinkies. So what you have is with M&Ms, you have a mixture of compounds. And we're going to load up these little trays with how many compounds are in there. This would be like the Julia Child, where you're really hoping I have one in the oven and I'm just going to pull it out, and that's not the case. So as I'm doing this, I will show that as you're doing through the process, that there's a number of different mixtures that are in here. So if you're taking things that you're assuming are all going to be uniform, and you take it out of 3 parts of a sample, it's possible, just by the way the material is in the bag itself, that you'll have a change in distribution. So typically what I tell people is that when you're pulling these out, got a red one, wasn't ready for that. And so as you're moving to that process, taking samples throughout the bag, if you're getting something, you want to make sure that you've gotten some of the things out of that 500-pound bag that are on the bottom, because that's where you're making the hash. That's, even though it's CBD, you're going to have a greater concentration more regularly from the bottom of the bag. So now, as I look at this process, which is probably more exciting to me than you, this is what we currently have, and we'll put these little guys over here to the side. So the ones that I don't want to have are the THC. So the THC comes out here. So you have a number of compounds. This could be your CBDA. This could be, put this one over here. This is your CBD, so it's coming out of a fresh plant. This is CBC. This is THC and CBG and CBN. So we've made these up. But what we want to do is even though we only have 2 of the red ones, if you take the math, add all these up, do I still have too many of the red ones? Because we want to get it below the number of compounds that are in that hemp. That's the whole process. At the same time, if you're doing a bad process and you're working through the process, I'm now going to assume some of these are going to be yellow. How am I going to do that? So let's say that I now have some green. So I'm put in 2 yellows. I take out 2 green. Now I'm betting. Now I'm in Vegas. I'm doing okay with the Vegas. What do you think, Betty? I don't know. You may be pushing your luck. And so as I go back through, I'm now I'm converting CBDA to CBD. So now what I should see is as the process is going, I have fewer greens, I have more yellows, and that's assuming I've gone at 100%. And I still shouldn't be changing these over here because I haven't impacted them much. But if I heat it enough, I want these to go away. So as you're looking at remediation and you look at other possibilities, the best way for remediation of THC is the gold standard is going to be chromatography. Somehow being able to, when you do chromatography, eliminating these just through the process of science. The more difficult about that is the fact that that's a high capital expense. So now, when I'm looking at this process and trying to emulate it all the way through the processing step, I do a couple other things. Each one of these steps is more and more refined. I like to use the analogy of blackstrap molasses. Use the analogy of moving to that through a more refined sugar, to a brown sugar, light brown sugar, and then you have pure sugar. And so each one of those is more and more concentrated, but you're losing some of the other things. So if you're only wanting the CBD or the CBDA, then having these 2 are the criteria, but you're not going to have the others. And now what happens is most people are looking towards a broad spectrum. So I move back to the fact of making a formulation-centric product. You want to know what you want to have in it, and then you have the separation, but you also want to be able to make sure that you have a variety that's providing you those compounds. A nice work that was done by Dr. Jerry King, is looking at the entire process. This is a good paper to look at, and as you look at each section of that, you're doing that with the testing as well as what you're doing with the processing, and knowing within each step what's happening. So on that side, there's pre-processing, like we talked about with the coffee. You're grinding, you're setting it in, you're being able to know what you do. Some people do decarboxylation before, some people do it after. Somewhere along that way, you have to draw out what you're trying to do and knowing where you're going to test it at each stage. All the way through the process. So let's look at some of the tools that are available right now that allow you to do it as inexpensively as possible. Most of the time, I'm just trying to get people to at least measure. So number 1, good is not a number. Fast is not a rate of speed. So you want to be able to have something that gives you an exact number of what you're doing. That's why you have a speedometer. That's why you have a tachometer. That's why you have what your oil pressure is, what your water temperature is. You need to know those in the process to be able to know that you're making a product that is the same every time. So one of the toys that I use is whether I'm doing ethanol or whether I'm doing propane or whether I'm doing any type of reaction, I'm wanting to start off with the smallest sample as possible. So in this case, this is a it's a supercritical fluid chromatography. Extraction, but you could also do it with some other mixed solvents, with some simple wing nuts here, to be able to take as small amount of the material as I can get away with and still have it be representative of what I'm trying to get. The last thing I want to do is fill up a 50, kilogram vessel and then find out that what I'm making it's got pesticides in it, or it's been contaminated with mold or something else. I want to be able to do an experiment that is much smaller. So within this, with these wing nuts and taking it off with my left hand to show that I'm not ambidextrous. Just because I can use my left hand does not make me ambidextrous. Just so we're clear. I'm almost done. So within this small vessel, you're able to put in the CO2, put the material in here, having CO2 here, moving the valves in such a way of your basic temperature and pressure that you're wanting to have, being able to collect an extraction on the other side, or also on this side, being able to do a more purification of an oil, for example, using it through an oil and cleaning it out separate ways. So you have a number of different facets that are available for you to do something on a small. There's also small ethanol systems. There's also small propane systems. There's ones that allow you to do it at a small scale at an inexpensive cost. The second part that you have to do is now being able to see what's in that compound. So, for example, of some of the studies I've done, take this off. Starting off with a mixture of different cannabinoids, and I know the camera won't catch this, but you can see the fact that even on this has a number of different dots in a different sequence. So the dots are exactly the same as moving it through my little scenario here. So if I was to tip this like this is the same way that I'm having these go back through. I'm able to have the green, it's separated based on how much time it is, and they really do separately select based on them all staying together. All the blues will stay together. So when you have that process, it allows you to have something very quick and very revealing in a short amount of time, and the expense is low. It's well below $500 just for an entire best kit that you would have for a TLC. And I also use the same thing with very large plates so that I can do a couple other things. I can do a large amount and then collect it, and then I can send it off for samples, so I can do preparative work as well as analytical. When you take and use that entire process, you're able to know at least what you have right now. The gating factor on this, though, is that the THC will not show up less than 1%. So if you're trying to get down to the 0.03, that's not going to happen because of the sensitivity and how much you can load on. You're not visually going to see it, but it will give you an indication of your CBD levels and the other cannabinoids, and it gives you an indication if it's greater than 1%, it's definitely going to show up, and they all have reproducible times. I also have something on my phone that's a TLC app. So I have an app on there that I can put it over, I can take a picture, and it will give me my retention times. It will give me, how big the spot is, and then I can do some qualitative work, at least a little bit of qualitative work, which is a nice little app for us geeky scientists. It gets us all excited. Oh, wow, I can do that on an app. Okay. Number 2, along the way, as far as measuring anything, is I do use a small product. 2 of them are based on spectroscopy. And when I'm looking at this type of product, what I'm really doing is I'm really just trying to get something one step higher than the thin layer chromatography. Within this kit, it allows me to have a small spectrometer, And the spectrometer has a window, a single window, and it allows you to be able to on site grind up a cannabis sample, place a vessel on the top, put the cannabis sample into the spectrometer, and then you get a reading within 1 minute or so on your iPhone. So when you're doing that, you're able to have, again, something that allows you to know where your CBD level is or your THC level. What it doesn't do is it doesn't allow you to have less than 2% on the CBD or the THC. So it'll have greater than, but not less than. So it gives you an indication of where your level is on the CBD for the plant. And if it's over 2%, you're already in trouble. But again, very quick, very easy, and fairly inexpensive to at least start off with. And it's easy to carry around. The next one I use on the next level up as far as sophistication is one that's made out of Israel. And within this case, it allows me to do similar types of spectroscopy and being able to test, but it does something a little bit better, and that is it will go down to the 0.03 level of the THC, potential THC. And it's about the same size. So when I'm doing more analysis and more sensitive analysis, I'll use something like this. It allows me to do a flower. So I have an accessory for just doing a raw flower, as long as the moisture is less than 15%. It allows me to be able to do a ground up flower. So I can look at raffinate or I can look at a grind and get a good answer. And it also allows me to do an ethanol oil. So with an accessory that allows me to do the oil, I'm able to do an ethanol oil to know what it's looking on the concentration. So it gives me more flexibility than the purple. It allows me to really, stick a hole in the flower and just be able to know what it is in about 3 to 4 minutes. There are other technologies out there that use IR, and they're well thought of in the industry also. These are just a couple that I have with me today. So then I look at, okay, how do I get a better answer? And one of the things to do is now you're having to rely on the chromatography. So you really need to have an answer that provides that. Now, again, there's a lot of different technologies that are available out there. This is just one of them that I use all the time, but a small liquid chromatograph, and it's able to give me 12 cannabinoids in 8.5 minutes. It's able to be totally self-sufficient as far as running a solvent through, capturing the waste, and giving an answer. So some of the nice parts about this is that as I'm going back through, I can also have a QR code on my phone. I can know what it's doing when I'm away from it. I can also go back through and capture all the raw data in a spectrographic form. I'm able to email myself answers, or if I have someone who's out in the factory and I'm up in an office doing something else, they can email me what the results are from an oil, from a 3-week-old plant, through all the different processes that you have in place. So totally self-contained 8-hour battery. So when you have that, now you have full documentation. You can be out in a grow, you can be in the extraction room, you can be doing raffinate, you could be doing a spent material. Each one of these providing you an answer in about 8.5 minutes. So typically people are using this type of technology with a small micron fitting particle, being able to get the answer and being able to have a full SOP. This is the one I use the most of the time because while I have good technology looking at the THC and CBD, with this one, I'm able to get the acids. I'm able to get CBD, CBDA, THCA, THC, CBCA, CBC, CBN, Delta 9, Delta 8, as well as looking at down to 0.03, looking for anything in the TH side, which they call hemp compliance. When you're looking at each one of those, again, your first step in each one of these is knowing where you are in the process. When I'm looking at this one, I'm actually doing an extraction of the material, and then after the extraction, I'm looking at the results. And so that's the key for being able to do it. With the IR or any of the spectroscopy, it's looking at a mixture and then doing a deconvolution. On this one, it's truly doing a separation and then testing each one of these. So the IR is more like having this mixture and then separating them through spectroscopy and chemometrics. The chromatography is more separation, more of a separation between each one and then measuring how many M&Ms. So this one's got 7, 8. Now I'm starting to feel like I'm playing bingo. D5, D5. So when you look at each one of these, now you're having an amount that's being given to you. The next level above this is to really move towards liquid chromatography. So for example, whether it's a manufacturer's chromatograph, you look at Shimatsu or Waters or Agilent or Thermo or just name a brand, but there's also now some specific ones that are small liquid chromatographs that look at the cannabinoids, up to 15 cannabinoids, and being able to see those on a very small chromatograph outside of the light lab, where some of them are able to be mobile, some of them aren't. This is very mobile. The Chemicert is less mobile because it has to be very specific in a quiet spot. This one I can bring out into the sun, and I typically do those. So when you're looking at extraction and looking at each part of your product, you're trying to figure out which one is the best solvent to use. And even within this process, you're being able to say, am I going to be using ethanol? What's the temperature of the ethanol? How do I measure the temperature of the ethanol while I'm running it? Or if you're running hexane, each one of these has a critical base to that, as well as without solvent. That's a lot of times what you're doing is you're making hash, or you're making something else that allows you to have a resin-based product. What's happening most of the time, though, is if they're not doing, for example, the hash or the rosin correctly, you are changing variables. You're changing. I've seen enough stuff with organic organic grows, and they have all this wonderful stuff, and they take care of the temperature, and then they use tap water, and that's you just go wrong solvent. The other one is with rosin. Sometimes you're doing pressing, but you're pressing too fast, and therefore you're creating temperature. So you put another variable into that. So when you look at that and you say, what's next? I would say, as we're moving through, we're going to find more handheld tools that you're able to use online. I would see how they have in the food industry. They're already doing IR. They do near IR to be able to look at the amount of water, to make the amount of fat as it's rolling really quickly by on wheat or rice. And so each one of those potential. Then you have the at-line, where you're being able to take a sample and then measure it. The other one to do next is the online. So being able to have something where you don't actually monitor, and it's constantly monitoring the different tools that are in there. And that's been used throughout the industry in other components, and you'll see it being used as we move forward. As we go through the laboratory, you'll see a lot of people spending millions of dollars on laboratory and then not investing $15,000 into testing the millions of dollars that goes through the to the facility. There are larger instruments that will show as you're moving forward and you're moving towards regulatory with some of the compounds. It's not just the extraction, it's now what are you doing in the process that's changing things. And there's a number of good papers out there that speak to the fact of what this plant is doing as you're working through the process that people are typically unaware of. Changes in the terpenes and changes in the cannabinoids themselves and the degradation, as well as, for example, when people are doing hemp, you'll hear about dewaxing, and they'll choose a solvent and they'll put it in the fridge, and then they believe they're getting the oil out, or they're taking all this stuff out of the wax and sucking it out of the wax, and that is not what's happening. You're leaving 10% back in the wax, and you're trying to figure out where did your yield go? Well, it went back into your process. What do you do to squeeze that out, or what do you do to have to make sure that you're not losing that? So testing along the way can save you. It saves you the cost of the instrument within a day with just one problem being solved. The second one is, as you're doing that, you're waiting for a COA to come back from another laboratory. And so now you're waiting weeks for something, and all you want to do is just get a quick read. If I was just wanting a quick read, I would definitely do a thin layer chromatography. It's the easiest thing to do. And so it gives you a quick indication if there's a change. And if you see something that is a change, then you move to the next part of chromatography, and then you can go out to an outside lab. There's more specificity, and of course, most of these are from the universities where the common person is not going to have that technology to be able to move through and know what's happening at this kind of molecular level. The work that was done in this paper is probably $800,000 just for the instrument itself, not to mention bungee cording your PhD to it. So as you look at the future, it's with solvent and without solvent. There's two types of concentration, because that's really what you're doing. You have a separation without solvent. That's like chromatography. Extraction, that's what you have when you're moving through and using a solvent, much like your salad dressing. And then what I call along the way is that you have a combination of them too. So with a solvent and without a solvent, you have a separation. So you have a mixture of the two analyses going. And the same thing happens when you have a hybrid in between, where you're transferring from one to the other. That's where the process will go. That's called PAT. The FDA loves PAT because it gives you something in line all the way through the process that helps out. I'm going to check the time. 1:19. So, any questions? So the man assistant went over his head, had bald hair. Yes? Question is it possible to get below 0.02? I do know of people that are getting below 0.02 on a large supercritical fluid chromatography, and being able to prove it on an analytical instrument to show that they actually did before and after. So they had their own internal lab, and then they also have a laboratory that will bring it down to that level. So someone way in the back can't always see what color my eyes are, but that doesn't mean that my eyes are non-detectable, right? So the better the instrument, that's what they did, is they really went to a high-end instrument to make sure that they were really seeing that through, liquid chromatography with mass spectrometry. The other way to do that is with a GC-MS. So now you have gas chromatography, being able to make sure that you have it, but within the gas chromatography, you can make THC out of CBD, so you're sort of playing with both ends of the fire stick. Go ahead. Did you want me to start from the beginning? Yeah. Yeah, so I would start from the hour ago. Yes. Say it again. Ah, so on a drug test, yes. So the nice part about THC and the bad part about THC or CBD is they're fat soluble. So they're accumulating in your fat somewhere along the way. And they're also, going back down into the liver, and the liver is making the metabolite. So I believe it was I was going to say University of Washington in Pullman. I think it's so that's not UW. That's Washington State. And it's UW. And so you go back through, and what they've done is they watch that rate of metabolism going down, and it's dependent on the human. So you can take CBD, and if you're not sure about the variety of the CBD that you're taking for a tincture, and if you have 0.3% TH3 in that MCT mixture, and then you take it 3 times a day, you're now up to 0.9. You're almost up to 1%. And depending on how much you take, because they're out there at 1,500 and 3,000 milligrams for a small bottle, it's also the concentration that's going into your body with that. So you can spike out pretty quickly with 11-hydroxy THC, because you do have it in your body. It really is there. Even more fun for the people trying to figure that out. So that's the answer is it depends. But it hangs around for days and days. The chances will be as high as the fact that they tested you. Because you will spike. You're going to spike. They're going to say that there's something in there, but I don't know how they actually do the final testing. But they'll find it. And so now that's why the military was saying that they couldn't use any, because how do you tell the difference between someone who's having THC and someone who's spiking with CBD? So it's very rare to have an absolute zero. Yes. Goes back to the concentration and your metabolism at time t, because you'll spike at different times of the day, you'll spike at different times of the week. So when they talk about it being a non-zero, if you do the math, so it's 6.023 times 10 to the forever 26 23rd. If you look at the number of molecules that are in there, and you do the math, even if you're at non-detected, I think I did it at like 0.01, you still have 3 million molecules in your body. You have to go back to the number of molecules in a mole, and that's when people open up their eyes. So there is an absolute zero. If I'm sucking on cauliflower, I'm not going to get THC, right? So if I'm sucking on something else, I will. But first of all, you don't suck on cauliflower. That's kale that you suck on. You don't suck on cauliflower. So when you go back through, that depends on what you're actually having. Here, wait. Here. You have to use the microphone. Wait, because I know it'll be good. So
Well, hi, my name's Catherine. I work at Big Sky Scientific and I'm an analytical chemist. So I'm always thinking about testing limits and things too. And so the question I was going to ask is if you thought there was a reasonable uh, bottom line for what we should consider standard for THC testing in isolates, because you can look deeper and deeper and deeper and you can get lower and lower detection limits, but they're not being used by most labs. And if we were to use, a couple of your instruments, I could test something, and if it's below 2%, it would come back non-detect or below the limit of detection. So what instrument you're using really matters, and that changes lab by lab. So is there a reasonable bottom level in your opinion?
In my opinion, I'm going with the 0.02, 0.03. I'm going with that as my detectable one because every time I run it, or if I do anything that I heated it, I'm right back up to it. I can't get rid, as long as I have CBD as my pro sample, I'm going to have THC. That ring is going to close up at, I think it's like 64, kilojoules per mole or something. It's really low to close that ring. So I think that's acceptable. Is that good? Do you have another one? Because we've mostly been struggling here. No. So there's no other questions and such. That I mostly just wanted to bring that to everyone's mind, and usually there's questions, so that'll take up the rest of the time. But if anyone wants M&Ms, that's how you separate them. You separate them with your little fingers. So I wouldn't take mine, but and I do the same thing with Smarties. And so when I'm training people on chromatography, I use M&Ms and Smarties because it's visual. So, all right, thank you very much.